Presentation on OpenGL. Welcome to this presentation on OpenGL. This session is part of the Computer-Aided Design and Manufacturing course. We will explore how OpenGL is used in 2D and 3D graphics rendering, its architecture, features, workflow, applications, and more. Let's begin by looking at the agenda for today's presentation. Agenda. In this presentation, we are going to explore the fundamentals and applications of OpenGL. Here's what we will cover. First, an introduction to OpenGL and what it is. Then we will look at the key features of OpenGL. Next, we'll examine the OpenGL architecture and its rendering pipeline. We will also walk through the workflow of using OpenGL in practical scenarios. After that, we will explore real world. Let's begin. We will discuss why learning OpenGL is important and wrap up with a conclusion. Let's begin with the introduction to OpenGL. Introduction. Welcome to this presentation on OpenGL, part of the Computer-Aided Design and Manufacturing course. OpenGL, or Open Graphics Library, is a cross-platform API used for rendering 2D and 3D graphics. It enables real-time and high-quality visuals across multiple platforms. What is OpenGL? OpenGL is a platform-independent graphics API managed by the Kronos Group. It is free to use and widely adopted in industries like gaming, virtual reality, CAD, and scientific visualization. It offers flexibility through customizable shaders and hardware-accelerated performance. OpenGL ensures wide compatibility thanks to its support from major GPU manufacturers. Features OpenGL. Some key features of OpenGL include cross-platform compatibility and hardware-accelerated rendering. It supports a programmable pipeline using GLSL. OpenGL shading language. OpenGL is an open standard with strong community support, and it easily integrates with helper libraries such as GLFW, Glue, and GLM. OpenGL architecture. The OpenGL architecture is based on a rendering pipeline. It starts with input, loading vertex and texture data into the GPU. Then, vertex processing applies transformations. Vertices are assembled into primitives like triangles. Rasterization turns shapes into pixels, followed by fragment processing, which decides the final pixel color. Finally, the image is rendered to the screen. Programmable. Programmable. The image is rendered to the screen. Programmable. Octane. Workflow overview. The typical OpenGL workflow begins by initializing the context using libraries like GLFW or SDL. Vertex data is loaded to the GPU using vertex buffer objects. Shaders written in GLSL control rendering behavior. A render loop continuously updates and draws a scene using OpenGL commands. Applications of OpenGL. OpenGL is used in various domains. In gaming, it powers real-time 2D and 3D rendering. In CAD, it enables design simulations and modeling. In scientific visualization, it helps display complex data graphically. It also supports virtual and augmented reality and is used in educational tools for teaching computer graphics. OpenGL tools and libraries. GLFW is used for window creation and input handling. Glue simplifies accessing OpenGL extensions, ensuring compatibility across devices. GLM is a math library for graphics, supporting vectors, matrices, and transformations. Freecla helps in building interactive OpenGL applications by managing windows and input events. Why learn OpenGL? OpenGL is highly relevant to modern industry needs. It's a gateway to careers in game development, simulation, virtual reality, and more. Learning OpenGL strengthens your understanding of GPU architecture and 3D rendering pipelines. Its wide adoption across platforms makes it a versatile and valuable skill. To conclude, OpenGL is a powerful and flexible API for creating 2D and 3D graphics. Mastering it equips you to build advanced visual applications and explore GPU-based rendering techniques. Whether for education, games, or simulations, OpenGL continues to play a key role in graphics programming. Thank you for your attention and participation throughout this presentation. We hope this session has provided you with a clear understanding of OpenGL and its importance in the field of graphics and engineering. Feel free to reach out with any questions or for further discussion. Once again, thank you and have a great day.